KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss about surface tension and surface energy. Okay, right. In our daily life, the mosquitoes can stand on drainage water. Similarly, the shape of the raindrop on surface of a leaf, right? Like this, I can give many examples where we can observe surface tension in our daily life. The name itself indicates surface tension. In case of liquids, the liquids exhibits or experience a free surface when you are going to take a particular liquid in one container. For example, glass of water. If you see the top surface of water, that is what liquid, which you can call it as free surface, right? So that free surface experience some tension. That is what I can call it as surface tension. That's what we are going to discuss in detail in this class. After completion of that, when there is a force, right, automatically the another physical quantity, that is what the energy will come into the action. That is what you can call it as surface energy. Surface energy, right? See, I just now, before 1 minute, I have given 2 examples for you. Not only 2 examples, we had many examples regarding this surface tension. Okay, that and all we are going to discuss now. See here. For example, if you take oil and water, which will not mix. Okay, and one more example. That is what water wets you and me, but not ducks. At the same time, mercury does not wet glass, but water sticks to it. Next, oil rises up a cotton wick in spite of gravity. Similarly, that is what soap and water, right, rises up to the top of the leaves, the tree. Okay, whatever it may be. Sap, that is what that is what the roots for a tree, right, which takes the water from surface, that is what inside of the earth to the branches of a tree. That is what he is saying. Next, heads of a paint brush do not cling together when dry and even when dipped in water, but form a fine tip when taken out of it, right? So here I am giving many examples, need not these many examples, but you can experience by taking any one example. We can go through in detail what is surface tension, what will happen because of surface tension, right? So all these examples, many more such experiences are related to the free surface of liquids, right? See, we already know very well, liquids have no definite shape, but have a definite volume. They acquire a free surface when you poured or when you have taken in a container. These free surfaces possesses some additional energy. possesses some additional energy. This phenomena is known as surface tension, and it is concerned with only liquid. It's concerned with only liquid because gases do not have free surfaces. Gases do not have free surfaces. Okay, that's what. So surface tension concerned with only liquid, not the gases. Not the gases, because gases does not have any free surface. Okay, that is. Next, here itself, surface energy. Surface energy, right? See here. Surface energy means, for example, see here, if you take a liquid which stays together because of attraction between the molecules, you just consider one molecule well inside the liquid. What will happen? The intermolecular distances are such that it is attracted to all the surrounding molecules. Am I right? It is attracted to all the surrounding molecules. Next, this attraction results in a negative potential energy. See this picture, see this picture also, right? See this picture. This attraction results in a negative potential energy for the molecule, which depends upon the number of distribution of molecules around the chosen one. But the average potential energy of all the molecules is the same. This is supported by the fact that to take a collection of such molecules and to disperse them far away from each other in order to evaporate or vaporize. You know what is meant by evaporation and what is meant by vaporization. For example, the heat of evaporation required is quite, for example, it is for water. For water, the heat of evaporation is 40 kilojoules per mole. See, what he is saying is, if you take a one molecule inside the liquid, it is going to attract, it is going to experience intermolecular force with the surroundings molecules. So this molecular attraction, this is intermolecular attraction, causes some potential energy. That is what? Negative potential energy. Negative potential energy. Okay, that is what the molecule is going to experience, right? Okay, but at the same time we have to keep in mind the average potential energy. Average potential energy of all the molecules is the same. Okay, right? Now we are going to discuss by taking one molecule as an example. See this picture, right? Here we have one molecule. So that is what? The molecule near the surface. The molecule near the surface. Okay, right? See, only lower half side. See here, it is the lower half side. Only so first, just now I told you by taking a molecule which is inside the liquid, completely inside the liquid. Now I am taking one molecule which is half the part is inside, half the part is outside. See the difference. So regarding this molecule, only lower half side of it is surrounded by liquid molecules. There is some negative potential energy due to this. Am I right? Because already we discussed in case of molecule which is completely inside the liquid. Okay. See different positions, right? One molecule just now we have taken which is completely inside the liquid. Now this is the molecule, half part is inside the liquid, half part is in the medium which is in contact with the liquid. Obviously it is air here. It is air. Okay, right. Because of this, because of having half part inside the liquid, it possesses some negative potential energy. But obviously it is less than that of a molecule. Obviously it is less than that of the molecule in bulk. That is the one fully inside. So the negative potential energy possessed by this molecule is less than the potential energy possessed by the molecule which is completely inside the liquid. Which is completely inside the liquid. Okay, right. So what can we say now? Approximately it is half of the latter. Thus, molecules on a liquid surface have some extra energy in comparison to the molecules in the interior. See, a liquid thus tends to have the least surface area. A liquid thus tends to have least surface area which external conditions permit. Okay, this is what you can experience. Suppose after rain falls, so if you are going to see that that is what the leaves of a tree. You know the water droplets are there, no? Right. The droplets having generally spherical in shape. spherical in shape. The reason for spherical in shape is surface tension. What is the role of surface tension means? You know that molecule tries to occupy the leaf, right, with less amount of area, That is the reason the molecule is going to get spherical in shape. Okay, right. Now, see, suppose if the molecule wants to increase the surface area, it requires more energy. So, increasing surface area requires energy. Right. Now, you can say that most surface phenomenon can be understood in terms of this fact. So, what is the fact? See, the molecule tries to be in contact with the surface with least area. Okay, that is what we can say. Now, some of the questions rise in our mind. That is what is the energy required for having a molecule at the surface? That is one thing. Generally, as we mentioned here, roughly it is half of the energy required to remove it entirely from the liquid. To remove it entirely from the liquid, that is half the heat of evaporation. See, when I am explaining this topic, you also please have a little imagination how one particular molecule is going to evaporate. For example, on one hot afternoon time, otherwise in summer, you are going to put one drop of water on one surface, that is, for example, on the surface of a floor, right? How it is going to evaporate? See, that molecule is the combination of atoms. First, one particular atom which is going to evaporate. Next, another particular atom which is going to evaporate. Next, another particular atom is going to evaporate. Like that, the total molecule is going to evaporate. This is the situation happens when all atoms present in one particular molecule are going to evaporate one by one. Okay, right. See, now we also need to discuss what is a surface. Since a liquid consists of molecules moving about, right? Generally, molecule is a group of atoms. Atom is the group of electrons, protons and neutrons. Okay, protons and neutrons are present inside the nucleus. Electrons are present outside the nucleus. That is okay. That is what structure of atom. Now, see, the liquid consists of molecules moving about. There cannot be a perfectly sharp surface. Is it possible to give a particular sharp surface to the liquid? Because there are so many factors. If you put, for example, on the surface of wood, if you put a water drop, you put one honey, a little bit of, right, like a drop. Next, put like coconut oil, okay. Then you put like petrol or diesel, something. So, then you can experience what is the difference in the shape of the molecule, right? That is the reason you can't give one particular sharp surface. See, there cannot be a perfectly sharp surface and shape of the liquid, but generally you can say that which is like spherical in shape. That's what we are going to discuss in our coming class. There we are going to define new physical quantity, that is what angle of contact. Okay, that will be in the next class. Now, the density of the liquid molecules drops rapidly to 0 around Z is equal to 0 as we move along the direction indicated in a distance of the order of few molecular sizes. See here, right? See this picture. This is what Z value and this is what R value and it is what A value because of these lines. Okay, anyhow, either from picture or the information what I am saying, right? You can get it. The density of the liquid molecules drops rapidly to 0. See, when density is going to decrease, density is equal to mass by volume, right? If mass will decrease, then automatically what will happen? The density is going to decrease, That's what we have to keep in mind mathematically, right? Density is equal to mass by volume. Okay, now see, we are going to understand at the same time what is surface energy and what is surface tension. Till now we discussed separately what is surface tension and what is surface energy. Now we are going to discuss at the same time, because the relation we want to know in physics, we want to know the relation between various physical quantities, right? As well as here also. See here. See these two things. This is what water layer. water layer. Okay, while getting the blood test, you are using some glass plates, right? So like those plates we used here, and first we are going to take one glass plate, and on the top of that we are going to put one water molecule, okay, liquid molecule. On that we are going to put another glass plate. Now if we are going to displace the top glass plate, that is what without changing the position of the bottom, you are going to change the top, then what will happen? The liquid acts like a layer between the two glass plates. So there you are going to apply certain amount of force. Automatically when you are going to apply certain amount of force, when there is a displacement, some work done will be taken place. Okay, that's what he is going to explain. And this is also related to the topic, that is what surface tension. Surface tension, okay, right. See, already we discussed in our previous discussion in the same class, as we have discussed that extra energy is associated with the surface of liquids, the creation of more surface, keeping other things like volume fixed requires additional energy. How it is possible to get like that? That we are going to get with the help of formula. How there is a requirement of additional energy to do like this. To appreciate this, you just consider a horizontal liquid film ending in bar free slide over parallel guides. See here, that's what I told you, by taking two glass plates, right, keeping one liquid in between them, and try to apply the force on the top of the glass plate. I mean, two are there, one is the top, another one is the bottom. I am asking you to apply force on the top, right? That is what he is saying. Now for example, suppose you are going to move the bar by a small distance d. See, this is the d amount, you can see in the picture, right? Since the area of the surface increases, area of surface will increase or not? You just think with your mind, right? Definitely will increase. You can see in the picture also, this is the area of the surface here, but here it is the area of the surface, right? So it increases a little, that is by an amount of d. That I will come to the conclusion. See, since the area of the surface increases, the system now has more energy. Right? This means that certain amount of work has been done against an internal force. Okay, right. See, for example, this internal force Bf means, what is the work done? By this force? See, suppose that we move the bar by a small distance d. What is the amount of work done here? Here we have written, that is what, F into d. See, already in the chapter of work power energy, we had a definition of work and we had a formula, that is what, work is equal to force into displacement, force into displacement. The same thing we are writing here, F into d, that is equal to Fd. But from law of conservation of energy, this is going to stored as additional energy in the film. For example, if the surface energy of the film is capital S per unit area, the extra area is 2dl, because the film has two surfaces, that is what, bottom and top. See here, a film has two sides and the liquid in between, so there are two surfaces. And the extra energy is S into 2dl is equal to F into d. Just he is balancing the energy, right? Because according to law of conservation of energy neither be created nor destroyed. Just it can be converted from one form to another form. Total energy in the universe remains constant. So from law of conservation of energy, because of film having two surfaces, you can write this expression. From this expression, you can write S as a subject, because dd will get cancelled. S is equal to F by 2L. So this quantity S is the magnitude of surface tension. It is equal to the surface energy per unit area of the liquid. Interface, and is also equal to the force per unit length. Exerted by the fluid on the movable bar. See, from starting of this class, we discussed conceptually and we discussed lively examples of surface tension, and we also discussed how one free surface possesses surface energy and what is the difference in the surface energy possessed by the liquid molecule which is completely inside the liquid, and by the liquid molecule which is half of the part is inside the liquid and half the part is in contact with the medium to that particular free surface. Okay. Now we are coming to the conclusion regarding mathematical formulas to calculate surface tension. That is what here S is equal to F by 2L. So conceptually, that is what orally in English words, what can we say? It is the force per unit length. It is as simple as such. Surface tension is defined as, that is what, force per unit length exerted by the fluid on the movable ball. This is the reason, you know, on drainage water, right, the mosquitoes can stand, they can put eggs also, right. So to kill the eggs of the mosquitoes, we are going to sprinkle kerosene. The municipal workers are doing now by sprinkling the kerosene on the drainage water surface, right. So this kerosene will decrease surface tension, then the eggs of mosquitoes, right, will go down to the water, then automatically there is no reproduction for mosquitoes, so that you can decrease the number, right. This is what happens generally, usually when the rainy season came. Okay, right. Now see, I am going to some other information regarding this surface energy, some more information. Okay, right. See, the surface energy in that case depends on the materials on both the sides of the surface, For example, if you take, if the molecules of the materials attract each other, the surface energy is reduced, while if they repel each other, the surface energy is increased. So you please try to understand. If the molecules attracts each other, surface energy will be reduced. Suppose if they repel each other, means the surface energy is increased. Surface energy will be increased. So what can we say more appropriately? The surface energy is the energy of the interface between two materials and depends on both of them. I will repeat once again. Surface energy is the energy of the interface between two materials and depends on both of them. Okay, right. Now one more point. See, surface tension is the force per unit length. I already told you, acting in the plane of the interface between the plane of the liquid and any other substance. Okay, right. See, for example, you are taking a glass of water. When you are taking a glass of water, if you see the top surface of the water, which is called as free surface of water, right, and which is present in the air, you don't forget that we all are living in air. Suppose if the glass of water will be in vacuum, that will be different situation. So should not think that we are in vacuum, right. So we are living among air molecules, so that free surface is in contact with the air medium. Suppose if you take the molecule which is inside the liquid, it has no interaction with the air medium. But if you take the molecules which makes the free surface of the liquid, which always be in contact with the medium, that is what? Air. Okay, right. So you can also say that at any point on the interface besides the boundary, we can draw a line and imagine equal and opposite surface tension forces S per unit length of the line acting perpendicular to the line in the plane of the interface. That's what he is saying, Isma. See, suppose you are taking a glass of water, you just imagine the surface molecules, right? See, these molecules are interacting with the air medium and also interacting with the glass medium. Am I right? But glass medium means I am not sure about all the molecules. The molecules which are in touch with, I think you are able to imagine a glass of water, right? The molecules which are interacting with the glass, surroundings molecules. But most of the molecules are interacting with air medium. That's what he is saying. Okay. Now, see, whatever the line you can draw, that will be in equilibrium. Suppose if you want to think more specifically, what can we say? The same situation. Just imagine a line of atoms. You just imagine a line of atoms, And there itself, if you see the molecules, right, after imagining a line of atoms, you just pull the line towards them. What will happen? What will happen, ma? See, then you can experience that line of atoms will be in equilibrium under tension. Under tension, okay? That is, it leads to this explanation, whatever I am giving, it leads to the discussion of what is angle of contact. Na? That we will discuss in the next class. There itself, it is very clear. Okay, just here he is giving information, basic information, how the line, what is the role of that line, and that line is going to give another new physical quantity which is called as angle of contact. Angle of contact. Okay, right. In this table, you can see the surface tension values of some that is what liquids, usually helium, oxygen, ethanol, and water, mercury, at different temperatures. So based on this table, one general conclusion is what? Surface tension depends upon temperature also. See, it is what? Helium at minus 270 degrees centigrade temperature, the value is 0.000239. Similarly for oxygen, right, at the same time heat of vaporization also. Here it is what? Heat of vaporization, and here what is the heat of vaporization, and for ethanol these are the values, then water, and then mercury. Okay, right. And this surface tension you can also measure, that is what, like in our physics lab, you can measure the surface tension for one particular free surface of a liquid. For example, if you take a fluid, it will stick to a solid surface. Okay, am I right or not? That is what, water on a wooden surface, water on the floor. So if the surface energy between fluid and the solid is smaller than the sum of surface energies between solid air and fluid air, solid air and fluid air. Suppose for example, if you take a water drop on the surface of wood, then wood will be in contact with the air, wood is in contact with the water, and water is in contact with air. So these many things, so different combinations, 3 combinations, right? So one is solid air and fluid air and solid fluid also, solid fluid also. Okay, right. Now we are going to do a small experiment. You can see in this picture, this is what measuring surface tension, you can say, measuring surface tension. This is what fixed. So it is like a material which can be in contact with the free surface of a liquid, that is what, uniformly. Okay, here this is like a weighing pan. Here we are going to keep a certain amount of mass. Okay, you can say that certain amount of weights. So we have to keep the weights so that this part of the object must completely in contact with the free surface of the liquid, okay. Then we have to note down these weights, how much is present there. With the help of this, and with the help of this is the formula, SLA is equal to W by 2L, that is equal to mg by 2L, you can measure surface tension. You can measure, basic formula is same, that is what, F by 2L. In place of F, here we are going to keep W. Okay, so directly you can measure with the help of this experiment. This is what, a flat vertical glass plate, and this is the weighing pat. Okay, like this. So this is the way of measuring surface tension for one particular free surface of a liquid. Okay, right. In this class we focus to discuss surface tension, surface energy, and then we came to discuss the expression to calculate surface tension, and we discussed surface tension values for different liquids, usually helium, oxygen, ethanol, water, mercury, and then we discussed a small experiment. With that you can measure the surface tension for one free surface of a liquid. So I request you to categorize this class into, first we discussed the concept, see how it is related to our daily life, what are the examples regarding the surface tension and regarding the surface energy, and then we understood how the molecule, whether which is inside the liquid, whether which is on the top surface of the liquid, possesses some surface energy, and then we derived an expression for surface tension, that is what, S is equal to F by 2L. Okay, Okay, this is the table which are giving constant values. Okay, after that we discussed a small experiment to calculate surface tension. Okay, right. In our next class we will continue with the next continuation topic, that is angle of contact. And after that we will discuss about drops and bubbles. Okay, thank you.